My name is Karin, and today I will be explaining the law of sines. You have already seen several rules in trigonometry, and today we will be expanding those rules so that they not only apply in rectangular triangles, but you can apply them in any given triangle. Let's start with a specific example. The top of a window is at a height of 7.5 meters. For safety reasons, the angle between the letter and the window should be between 20 degrees and 30 degrees. Moreover, the sidewalk in front of the house is not horizontal and forms an angle of 95 degrees with the facade. The question now is, could you safely lean against the wall just above the window with a ladder of 8 meters? So let's look at what is given. We know that the window is at a height of 7.5 meters. We also know that the facade and the sidewalk form an angle of 95 degrees. The question is, will a ladder of 8 meters do to lean safely against the wall? We've translated this information into a mathematical picture. During this video, I will be asking several questions. It's good for you to press pause, take a second, and then when you know the answer or have an idea what we're talking about, press play again. So now the question is, how would you solve this? How would you solve this problem? We already learned several rules in a rectangular triangle, as I mentioned before. But now, since the facade and the sidewalk form an angle of 95 degrees, we cannot use those rules. So we will be examining what we can do to solve the problem. Let's have a look in GeoGebra. We will use GeoGebra to investigate several things. We divide the side of a triangle by the sine of the opposite angle. What do you notice? We see that this always gives us the same value. The question now is that the case if we change the angles? We see that this always gives us the same value. This is what we call the law of sines, or the sine rule. So according to the law, A over sine of A equals B over sine of B equals C over sine of C, where A, B, and C are the lengths of the sides of a triangle, and capital A, B, and C are the opposite angles. Let's prove the law of sine so that we can use it in the example that was given. Given is a triangle ABC that is non-rectangular. How could we prove the law of sines? We will prove it in two parts. In the first part, we will prove that B over sine of B equals C over sine of C. The question is, how could we do this? If you draw the altitude AF, you create two rectangular triangles. In triangle AFC, sine C equals AF over B. And in triangle ABF, sine B equals AF over C. This because of the definition of sine of an angle. If we now seclude AF, we see that AF equals B times sine C. And we see that AF equals C times sine B. If we now equate the right members, we can see that B times sine C equals C times sine B. This means, because of the main property of proportions, that B over sine of B equals C over sine of C. So we've now actually already proven the first part of the law of sines. In part 2, we will prove that A over sine of A equals B over sine of B. How could we do this? Once again, we will draw an altitude. The altitude CD creates two rectangular triangles, CDB and CDA. You could draw another altitude, and that is also correct. In triangle CDB, sine of B equals CD over A. And in triangle CDA2, sine of A2 equals CD over B. This once again because of the definition of a sine of an angle. If we now seclude CD, CD equals A times sine B, and CD equals B times sine of A2. If we equate the right members, A times sine of B equals B times sine of A2. if you take a look at what we're trying to prove and what is in our proof at the moment, you see that we're talking about the sign of A2 and not the sign of A. We want to be talking about the sign of A. So the question now is, what is the relation between A2 and A? These are supplements, and we know that the signs of supplements are the same. So now we can conclude that A times sine of B equals B times sine of A. And once again, because of the main property of proportions, we can conclude that B over sine of B equals A over sine of A. If we take a look at part 1 and part 2, we now see, and we can conclude, that A over sine of A equals B over sine of B equals C over sine of C. So we've now proven the law of sines. In other words, we can say that in any triangle, the sides are proportional to the sines of the opposite angles. I hope that this was clear to you and that you can now use it in any given example. Let's try. To examine if you could safely lean against the wall, you can now fill in the values that were given in the example in the beginning. Using the rule of sines, or the sine rule, you will now conclude that B does not lie between 20 and 30 degrees. This means that you cannot lean safely against the wall above the window. I hope this was clear to you and that you now have an idea of the law of sines.